All right, boys and girls, little 5-minute lesson here on perpendicular and angle bisectors. Okay, so let's take a look at the letters or the words. A perpendicular bisector is done to a segment. So here we have a red segment, AB. Okay, the perpendicular bisector of that segment divides the segment into two equal parts and is perpendicular to it. Now, we're going to learn about this term equidistant. Okay? Every point on this green line is equidistant, the same distance from A as it is B. You see that? So there are going to be three primary shapes that you should look out for when you're looking for perpendicular bisectors. One of them are isosceles triangles. So if you have an isosceles triangle, then the altitude is also the perpendicular bisector because the points are equidistant. Another one looks like a kite. So if you have something that looks like this, then you know that it's been perpendicularly bisected, that segment. Okay, I should get my right angle there. And then another one looks like, you guys probably don't know what this is, but like a Star Trek symbol. Some of you do. Stop. So if you have So let's look at this segment AB down here. You've got two segments, or 2 points, that are the same distance from A and B. So if I drew a line through those points, it would make the perpendicular bisector. Okay? Now, angle bisectors bisect an angle. So if I have an angle, I could draw a ray, a line, or a segment that cuts that angle into two equal parts. So now, I'm going to kind of quickly scroll through this deck and try to hit on some maybe key information. So look, if you wanted to build a new high school in between Brighton and Springfield Middle School, you would have to construct a perpendicular bisector. And now you can build the high school anywhere on this perpendicular bisector. And those points will be equidistant from both schools. Okay? So, this is kind of a review of what we did. How can you find points that are equidistant from the endpoints? You have to construct the perpendicular bisector, okay? So now we've got two theorems. If a point is on the perpendicular bisector, then it is equidistant from the endpoints of a segment. If a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector. So we now have the perpendicular bisector theorem and the converse to the perpendicular bisector theorem. How will we construct this? We'll do this in class next week or today actually. We'll do it today when we see each other. But it's pretty simple. Look, you're going to take, well, actually we'll just do it. You guys will experience this together in class. If not, just pause the video, take a look, and see if you can figure it out. You're basically just drawing two congruent circles and connecting their intersection points. Similarly, we'll go over how to construct a perpendicular line. Here's how you would use constructions to actually do this in real life. This looks like Oak Island down here. I hope none of you guys watch Oak Island. And here's one that we can review that will apply it into a more traditional math setting. What is the value of AD? Okay, so look, what's going on here? They tell you that these are congruent, and they tell you that this is a right angle. So now you know that AC is the perpendicular bisector. Well, then that means that AB is congruent to AD. So then you can say 6x plus 10 equals 3x plus 2. Solve it, you get x plus 4. Plug it back in, and you get AD and AB are both 14. So this is a pretty classic type of question. Find equidistant points from the side. Let's see. So what this is telling you is that if you have a point on the angle bisector, that point is equidistant from each segment. Now remember, we measure distance at a right angle. Like when your doctor takes your height, he's measuring the distance from the top of your head to the floor. And they tell you to stand up straight. They're basically telling you to form a right angle with the ground. Because if you didn't, like if you could stand up not straight, then you wouldn't be measured as tall. So it's the official way we measure distance. We measure it at a perpendicular. So if a point is on the bisector of an angle, then it's equidistant from the two sides of the angle. If a point is equidistant, then it's on the angle bisector. So we'll be using those. Okay, that does it. Boom.